In this week's tutorial, I'll guide you on how to integrate the SonarQube scanner into a Gitlab CI/CD pipeline. No prior knowledge of SonarQube or Gitlab is necessary to follow along. To get started, we need a project to analyze. Luckily, I found a great candidate on GitHub, a web platform for ethical hackers to practice their skills. This will allow us to compare what vulnerabilities Sonar finds with what's already known. Since the project's on GitHub, we'll need to import it to GitLab. Don't worry, I already took care of that. Importing projects is a breeze, and if you're interested, check out my previous videos where I walk through the process. Before we create the CI/CD pipeline, it's always a good practice to run the scan locally first. This helps identify any issues with your pipeline configuration before pushing things to the cloud. So let's clone the repository to our machine. While I'm using a MacBook for this demonstration, the commands we're using are compatible with Linux and Windows machines as well. Now let's head over to SonarCloud at sonarsource.com. Notice that I connect to SonarCloud through GitLab. This ensures they can communicate and analyze your code. Click the Analyze New Project button to get started. We'll see a list of available repositories, but since we're doing a local run, we'll create a project manually. We'll name the project Sonar Scan Demo. You'll also see the project key, which we'll need for configuring the scans. Next, choose how SonarCloud handles new code. We'll select number of days for this example. This means that any code that has changed in the last 30 days is considered new. If no action in that time frame, it becomes part of the overall code. Feel free to experiment with this setting to find what works best for your development process. Next, we'll choose the analysis method. For a local run, we select Manual. Then we need to specify how the project is built. Our project uses Node.js, so we select Other. I'll also quickly show you Maven, Gradle, and .NET. To run the scan, we need the Sonar scanner. Instead of downloading binaries, we'll use npm to install it. If you're developing a Python application, visit the GitHub page of the PySonar scanner to find the installation command. For Maven projects, create a POM file to set project properties like organization and Sonar host URL. The project key is defined as a parameter in the run command. Gradle users need the SonarQube plugin and build Gradle properties set for project key, organization, and host URL. For .NET projects, use the .NET tool install command. Then in the run command, provide parameters for organization, project key, and host URL. Let's proceed with our project. First, export the Sonar token as an environment variable. Finally, copy and paste the correct command to execute the Sonar scanner. Since I installed the scanner with npm, I need to add npx in front of the command. The analysis was successful. You can view the results at sonarcloud.io. When we return to our browser, the project page has already been updated, so we can see the results there. There are 7 security issues, which is what we expected. Now we can proceed to run the scan in the GitLab pipeline. From the project page, open the administration menu and select Analysis method. There is a link for the Gitlab CI/CD pipeline. Here are the instructions for analyzing the project in a GitLab pipeline. First, we need to add a couple of environment variables, so let's head to the GitLab page and click Settings, CI/CD and Variables. It's important that the Sonar token is a masked variable. This prevents the token from being visible in the logs and leaking outside the development team. The second environment variable we need is sonar_host_URL, which should be set to sonarcloud.io. The next step is to add the necessary lines to the YML file that defines the pipeline run. If you use Maven to build your project, first define the organization in the POM file. Then copy the lines below into the YML file. The project key is a parameter of the Maven command. For Gradle projects, define the organization and project key in the build Gradle file. Below, you can see the YML lines to copy to GitLab. Alright, let's continue with our Node.js project. I'll copy the YML lines. Open the pipeline editor and click the Configure button to create a template. Let's add a new stage called Sonar, and keep the other stages to mimic a real-world project. We'll just remove some unnecessary sleep commands to speed things up. The code example is good, but we'll just add the stage name. The editor indicates that the pipeline syntax is correct, so we can commit the changes. Hold on, it seems our Sonar stage is missing. Let's cancel this run for now. There's a reason for this, and I want to show you what happens if you encounter the same issue. The problem is that our branch is named main, but the Sonar stage is currently configured to run only on branches merge requests, master, and develop. Let's simply update master to main and try again. Another failed job. Again, I anticipated this error and let it happen for a reason. We haven't completed step 3 in the instructions yet. If the order of the instructions was different, you might not have encountered this issue. However, I wanted to demonstrate what happens if you skip a step. We need to create a Sonar project properties file to define the project key and organization. Great news, our analysis was successful. You can see it on sonarcloud.io. The quality gate passed with 0 new issues found. This is because all the issues were identified during the local run, so there weren't any surprises in the pipeline. Let's take a closer look at the previous run to see what Sonar Scanner discovered. We're primarily interested in security issues, but let's quickly glance at the non-security findings. Use const instead of let. Use varchar 2. Remove commented code and so on. Now, onto the security issues. The first one is a SQL injection. Sonar not only shows the location of the issue but also provides clear explanations on why it's a problem and how to fix it. We see another SQL injection on line number 96. It seems all these issues are similar SQL injections popping up in different parts of the code. In total, we found 7 SQL injection vulnerabilities. Next, let's look at security hotspots. Ensure the content length limit is safe to prevent denial of service attacks. There are 2 such issues in 2 locations. The Docker file also has a couple of security concerns. Copying recursively might add sensitive data to the container. Another problem is that the node image runs with root as the default user, which can be exploited in certain cases. Finally, we have 2 low-priority issues: a framework disclosing version information and a missing ignore scripts parameter. Sonar Scanner did a great job. However, if you look at all the potential vulnerabilities, there are cross-site scripting, remote file inclusion, file upload, cross-site request forgery, and session hijacking, which Sonar did not detect. If you're interested in seeing how other SAST scanners detect these issues, check out the video in the description. While SAST scanners don't guarantee perfect security, some of the scanners I demonstrate in other videos can detect additional vulnerabilities from this list. That's it for today. We covered running Sonar Scanner locally and integrating it into your GitLab pipeline. If you have questions, leave a comment below. If you enjoyed the video, share it with your colleagues. Thanks for watching.